Hi, my name's Paul Gretton. I'm the project manager on the ERDF project, which is a European Regional Development Fund project called APF. APF is the advanced prototyping facility here at Aston University and is designed to help SMEs with prototyping and manufacturing problems which they have, using additive manufacture, which is a whole new way to manufacture products using 3D printing. We are here to assist SMEs across a whole range of different sectors, whether it be your standard manufacturing, to your jewellery and your agriculture and your food and beverage. Additive manufacturing / 3D printing is used for a wide variety of applications now.
It's really helpful for companies to come to us and just get that extra little finalising of the design. It could just be that the company needs a new set of eyes to look at the product, or they need someone with a bit more experience in the manufacturing side. Even just producing a 3D printed prototype can help immensely.
For the Hydrovac project, we used FDM technology, one of the most efficient ways to produce the prototyping part of the turbine.
Part of our remit within Assemtron is to solve engineering problems for our end customers. One of the projects that we picked up, which is quite a large project, was to capture live data from a water main for the infrastructure system and to measure parameters such as battery levels, flow rates, temperatures and pressures. The problem we had was to develop a suitable turbine mechanism that could generate enough power but also deliver the flow rate values that we needed. We engaged with Aston University initially to use their expertise in the design of the rotor system that we were going to use, and then the project evolved through a number of iterations and ended up with us making a number of different rotor configurations and then fine-tuning that, looking at the data that was derived from the system. The team at Aston initially started looking at the dynamics and the modelling of the application, so solving the mechanical problems, but then quickly moved on to material selection and additive manufacturing techniques. One of the challenges in an industrial environment is that we wanted solutions yesterday, as ever, and we were able to move through a lot of iterations quickly, initially using 3D printing and also using specialist manufacturers that Aston had introduced to us for more sort of exotic material moulds and things. Where we are now is we're entering the final phase of the development side of the project, and we're now looking to gear up for volume manufacture. We've worked closely with Will and the team on materials selection and additive manufacturing, and we're now looking at processes to take prototypes into a form that we could make in volume. Had we not had access to the engineering teams at Aston University, the first challenge of modelling the system for dynamics is frankly something we didn't have in-house, and we would have had to look externally for that expertise. But also throughout the process there have been areas where we've needed different types of expertise, for example additive manufacturing. There are commercial sources for that, but finding the solution in an easy to access form would have been difficult. One of the hidden benefits of working with Aston University is that the process works in two directions. As we've developed that working relationship with the teams, multiple teams at Aston, we have met up with and started working with a number of offshoot companies like ourselves where we've got complementary skills. On the back of that, we've taken the decision to join the industry club, and we're now openly supporting that move. For example, on projects where we're at the core of the project, we're now looking at projects where we're interacting with rotational moulders, moulding machine operators, and other engineering skills that we frankly don't have or wouldn't necessarily want to bring inside our own business.